morning, my darlings. We are starting sound in our science book. Yesterday, you were to have read this first introductory to sound on page 217. So we are going to go ahead and get started with reading through our chapter and highlighting the necessary information that we need. So go ahead and get your science books, get a highlighter, and open up your books to page 218 is actually where we're going to start. So on page 218, we're going to label this quiz 9A. And we are discussing the property of sound waves. We'll start reading and then we'll highlight when we get to the information that needs to be highlighted. Engineers like Mr. Fogel must understand sound to design technology that can be used to help others. What do you know about sound? Sit quietly for a moment and listen. You may hear the hum of air moving through a vent or the ticking of a clock. Perhaps a noisy truck or train is passing nearby. A chair may squeak or shoes may rustle on the floor. Although each sound is different, all sounds are made in a similar way. Each sound started because an object moved. Vibrations and waves. The movement of an object causes vibrations. A vibration is a rapid back and forth movement. Sound is a vibration that can be heard. Go ahead and highlight those two sentences. The ticking that comes from a clock is caused by the movement of the parts inside the clock. The parts vibrate as they touch each other. They cause the air molecules around them to vibrate too. These vibrations blend together to make the ticking sound that you hear. Sound moves through matter in waves. A wave is a disturbance that moves energy from place to place. Go ahead and highlight that. And we're moving on to page 219. The matter through which a sound wave travels may be a solid, liquid, or gas. Most of the sounds that we hear travel through the air. And here is a picture here of parts of a sound wave. And you can go ahead and highlight this section up here on the top. Sound energy moves from the vibrating object to the ear. You hear sound because the vibrations of sound energy cause your eardrum to vibrate. As the vibrations are carried through the bones of your middle ear, the vibrations are changed into nerve messages. Your brain then interprets these messages and tells you what you hear. Sound waves can be described as mechanical waves. Highlight that. I'm taking my watch off. It's bothering me. Mechanical waves must have matter to travel through. Energy causes particles in the matter to move and vibrate. Sometimes you can feel sound waves. When you hum, you can feel the vibrations that your throat makes. Those vibrations cause the sound that you hear. Other sounds that you might feel are loud thunder or the beat of a bass drum. In a sound wave, the particles of matter vibrate back and forth in the same direction that the sound energy is moving. The motion of each vibration pushes together some of the particles of matter. This part of the wave is called a compression. As the motion of the vibration moves away from the compression, the particles spread apart again. This part of the wave is called a rarefaction. Waves continue to form as long as the object vibrates. The way sound waves move is similar to the way a spring toy moves. If you stretch out a spring toy and push one in, the coils of the spring move back and forth as the wave passes to the end of the spring. The particles of matter are not carried along with the sound wave. Each particle vibrates but remains in its place. Imagine what would happen if air particles were carried with the sound waves. Sound waves from a choir singing would cause a wind to blow. All right, go ahead and label page 219, quiz 9A. And then we're going to turn the page. Frequency and speed. Sound waves cannot be seen. Excuse me, let me see if the book is in the view. Okay. Sound waves cannot be seen, but they can be measured. The distance from one compression to the next is called a wavelength. Different sound waves have different wavelengths. These lengths are determined by how quickly the source of the sound vibrates. Sounds that vibrate quickly have short wavelengths. So right here, this is what's called the compression when it's pressed together, and then whenever you start spreading it out is the rarefaction, and all of that is in the same wavelength. Machines and tools have been developed to help us see pictures of sound waves. An oscilloscope, I'll have to look that up to make sure I'm pronouncing it correctly, uses a type of microphone to convert mechanical sound waves into electrical impulses. The impulses are shown as a wavy line on a graph. So here it is on the screen what it would look like. The number of sound waves per second produced by a vibration can vary. As the number of waves changes, so does the frequency of the sound. Frequency is the number of waves that pass a point in 1 second. Highlight that. Frequency is measured in a unit called hertz. Sound waves travel in all directions, away from the source of the sound. A sound wave can also travel through different types of matter. The siren of an ambulance can be heard whether you are in a house, in a tree, or underwater in a pool. Sound waves move at different speeds in different types of matter, though. The density, or how close the matter molecules are, affects how quickly the vibrations move from one particle to the next. The density of the matter also affects how far the sound waves can travel. Sound needs particles in order to move. Of the 3 states of matter, gas is the least dense, so sound moves the slowest through gases. The sound energy cannot easily move from particle to particle. Also, some of the energy gets used up as it travels through the spaces between the particles. This slows the movement of the waves. Air is the most common type of matter through which we hear sounds. The speed of sound in air is about 335 meters, which is 1,100 feet per second. This is how fast sound travels through, go into page 221, the air under specific atmospheric conditions. In different conditions, such as a hotter day, the speed of sound will be different. The particles in liquids are denser than the particles in gases, so sound moves more quickly through liquids than it can through gases. The waves also travel farther than they can in a gas. Solids are the densest state of matter. Their particles are very close together. The sound waves easily move from one particle to the next. So sound waves can also travel faster and farther in a solid than in a liquid or a gas. Go ahead and highlight that sentence there. The speed of sound is not the same as the frequency of sound, vibrations. Speed tells you how fast something is moving. Think of watching cars traveling on a straight highway. Suppose all the cars on this highway are traveling at 50 kilometers per hour. That is the speed of the cars. However, the frequency of the cars is the number of cars that pass you in a set period of time. Frequency is how often they pass. In the first minutes, perhaps only 1 car passes. In the next minute, 5 cars may pass. The speed of the cars stayed the same, but the frequency changed. The speed and frequency of sound waves are related in much the same way as the speed and frequency of the cars on the highway are related. And then right here we have a quick check, and I want you to answer these questions for me. Number 1, what is sound? Number 2, what is a wavelength? And number 3, through which type of matter can sound travel faster, a gas or a solid? Make sure on the bottom of your page you've labeled this quiz 9A. And just for your information, to repeat this, we are not doing tests and quizzes while we are at home learning, but this is still the information that would be needed if we were to take a quiz and test. So we are conduct our classrooms at home the same way we would if we were at school. So that's why we're still having you highlight, we're still having you label your textbook, and we're preparing you to be ready for 6th grade. So with that information, for all the different sections we just read, we started on page 218. That started our quiz 9A. 219 was quiz 9A. 220 was quiz 9A. And 221 was quiz 9A. So we've read, we've highlighted, and now I want you to answer your quick checks and let me know if you have any questions. All right. Thank you, guys.